The first gas law we'll talk about, hopefully you've heard of it before, is called Boyle's law. Boyle's law relates pressure and volume. And what it says is at the same temperature, volume is indirectly proportional, inversely, to pressure. So we write this out as P1V1 equals P2V2. So the pressure times the volume equals the pressure times the volume. So here, if you have this pressure and volume goes up, pressure goes down. So as one goes up, the other comes down. So that's why they are in an inverse relationship. Volume goes down, pressure goes up. Pressure goes down, volume goes up. So inversely. So the body does this in your lungs. So if you've taken one of my anatomy classes, we talk about this. So in the lungs, everybody just kind of sit up straight. Now, when you take a deep breath in, your diaphragm, which is kind of right around your belly button there, it moves down and creates more space. So it increases the volume, which decreases the pressure that's in your lungs. So air from the outside comes in. And then when you're ready to exhale, the diaphragm relaxes, so it moves back up. As it moves up, there's higher pressure, and the air in your lungs is forced out into the air. So it's a neat concept. My sister is a nurse anesthetist, and so she uses gas laws very frequently. So if that's a field that you're interested in, this is important. So if you ever wonder, where am I ever going to use this? You will use it. So let's try some calculations here. A woman has an initial lung volume, and it is 2.75 liters. Filled with air, here's the pressure. If she increases the volume of her lungs, but she doesn't actually inhale any more air, so same amount of air, what's the new pressure? So the important thing here is make sure you just pair things up correctly. So we know that P1V1, P2V2, it does not matter which pair is 1 versus which pair is 2. Just make sure you pair them up together. So the first pressure that I see is this one. So 1.02 atmospheres. And it goes with which volume? 2.75 liters. Second pressure, we don't know, that's what we're trying to figure out. Second volume, 3.25 liters. So you can see here that liters are going to cancel out. And so just get P2 by itself. So 1.02 times 2.75. Let's divide that by 3.25. So now our new pressure is 0.863 atmospheres. So you can see the inverse relationship. Volume went up, pressure went down. Let's try a couple more. So a snorkeler has a syringe, and it has 16 milliliters of air. The pressure is 1 atmosphere to an unknown depth, but the new volume is 7.5. What's the new pressure? All right, match them up. So P1V1, P2V2. First pressure, 1 atmosphere. First volume, 16 milliliters. Second pressure, we don't know. Second volume, 7.5 milliliters. This is sort of like a dilution. As long as the units are the same on both sides, you don't have to convert them. So milliliters will cancel out. So here we need 16 divided by 7.5. 2.1, just 2.1. Two's even figures. P2, 2.1 atmospheres. All right. Next, chlorine gas, initial volume, 35.6 liters. Now has a volume of 27.2 liters at this really high pressure, 15.6 atmospheres. What is the initial pressure? Okay, so P1, V1, P2, V2. What's our initial pressure? We don't know. What's our initial volume? 35.6 liters. What's our second pressure? 15.6 atmospheres. Second volume, 27.2 liters. So 15.6 times 27.2 divided by 35.6. Liters are going to cancel out. So pressure 11.9 atmospheres.